Imagine if an agentic AI could analyze every equity portfolio on the planet. Build any portfolio you can imagine instantly. Upload any existing fund and watch AI enhance it in minutes. Developed by Arabesque AI, AutoCIO enables investors to design, monitor, and implement AI-driven strategies with minimal intervention, delivering customization at extraordinary speed and scale. AutoCIO combines daily AI forecasts with advanced analytics to test and refine portfolio ideas at scale. Throughout the entire process, the AI assistant works alongside you, supporting every decision from analysis to execution. Ask questions, uncover opportunities, and act using simple, natural language. Behind the scenes, autonomous AI agents analyze data, generate insights, and execute complex tasks within AutoCIO's multi-agent computing platform. AutoCIO, your personal AI co-pilot for portfolio management.
Incredible to see so many of you here tonight. And also welcome to everyone who is on the live stream. We've got about 3,000 people dialing in globally, which is incredible. So we had an extraordinary interest in this event. And I think that's the testament of the fact that we're going to talk about a topic which is super relevant and important to all of you. And I can't wait for you to listen and also engage with our amazing speakers tonight.
There's no doubt that the industry has gone from basically active to passive portfolio management, and we're probably going to go from passive to autonomous portfolio management in a not too distant future. And there's probably nobody on this call who doesn't deal with customization issues for clients, who doesn't deal with how to comply with the new regulation, and also with the margin pressure. So the question is not, is AI suitable for this or not? The question is, where does it come into the production process? And we thought that the solution is not to be upstream, more analytics, more signals, more risk models, that kind of stuff. The bottleneck is actually at the decision-making process. So the question we ask ourselves is, how can we leverage decision-making? At the moment when the portfolio manager wants to decide to keep a position, to sell or to buy, that's basically where we want to come in, and that's basically what we have built and want to share with you tonight. So thank you again for being with us tonight. Thank you, Google, for hosting us, and handing over to Heiko.
As you probably have heard many times last year, 2025 was supposed to be the year of agents. I like to think of it more of a year that everyone talked about agents, but we are now at a point where models and frameworks are good enough that we can start implementing actual multi-agent systems.
What distinguishes today's agentic and multi-agent AI from what was happening 2 years ago? So I'll start with Heiko.
So 2023 turned out to be very much the year of chatbots, not only ChatGPT, but basically very quickly everyone understood how to build a product like ChatGPT, not in its sophistication, but how to basically interact with an AI model, get a response back, and show it in a user-friendly UI. So we started then in 2023 working with customers who built exactly that, like a chatbot that I could maybe give a document to and it would summarize it or write me an email about it and so on. And then also towards the end of that year, we started with retrieval augmented generation. So we understood that these AI models, they have a knowledge cap up to the training data they've been trained on. But if I ask them who's the Prime Minister of the UK, and I think around that time it changed like every 6 weeks or so, it would not be able to tell me the truth. So we learned how to pull in external sources. And so we got this kind of first workflow, deterministic workflow with AI. I ask a question, it will be translated into a search. The search will be executed. I get some results, and those results will be then sent to the AI model again to give me the results in natural language. Now we start slowly to see these multi-agent systems where there's actual agency in the system. So a request comes in. I don't think it's too much of a spoiler to mention the multi-agent system with the customer I worked with last year. It was a commerce customer, and it was a shopping agent system. So a question or a query would come in, and the system now decides by itself, well, who should I route this to? Should I route this to the image search agent, or should I route this to the agent that goes through the past orders for that customer? And it decides which tools to use. So we now get into a stage where we actually have these agentic systems that have autonomy in order to solve a problem. We don't prescribe it anymore. And that also can do now, slowly but surely, act on the user's behalf.
Why do you think specialist models are so important, particularly if you can address it to finance?
I think that so actually I'm working on augmenting current neural architectures with some kind of memory to make them more capable in reasoning, in continual learning. So that, because current models, if you just remove all the context, they will just forget everything they've seen, and you can use like RAG or something like this to push data in. So in future, we expect that we will have models which can have this type of lifetime learning. And working on these models, we see that actually we already discussed this. We had LLMs, and LLMs, they are universal. They can solve problems in natural language. But then, if we talk about agents, are they just shallow warpers around LLMs, like interfaces? I have very smart LLM, and I have interface for controlling web pages. I have very smart LLM, and I have web interface to control car, something like this. Or we should consider that actually, even if natural language is very expressive, and it can describe a lot about our surrounding world, including like all our programming stuff, which can describe how to do something in the world, still we need more knowledge about different aspects of the world as well. And here I subscribe to this view that we need more different, like we have language model, probably we should have financial markets model, or we should have a traffic model, or we should have a genomic model, or anything else, because the nature of the data might be different for different domains. So probably we should not bet on one universal model as AGI to solve all problems.
How is AI and tools like Auto-CIO, changing investment workflows?
Yeah, so we use AI in two different ways. For many years, so we've been building this for over 10 years, we have our own financial market foundational model. That's the alpha model. The goal there is to essentially forecast or give a kind of view about the future direction. And in there, we kind of forecasting using, we use a deep learning architecture or an ensemble of deep learning models. And in there, we're forecasting around 50,000 equities every day. And so if you look at that, to train those models requires tens of billions of different financial data points just to train those models. So it's not something feasible or even suitable at all to an LLM kind of system. So this goes back to what Mikhail was saying about kind of specialized models. That's a specialized model. And then the other area that we do in the system, where the other area is the agentic system. And so just taking a step back, once we have our alpha signals, that's not what we're delivering. We're delivering portfolio. So hyper customization, be able to basically build custom investment strategies or to augment an existing portfolio. So maybe I have a portfolio, I'm not exactly sure how I want to optimize my weights. I know what stocks I want in my portfolio, and that's the augmentation part. So in that case, we have then a kind of, like I was saying a little bit earlier, around a portfolio optimization. So you have alpha ingredient from our kind of foundational financial system. You have the portfolio optimization. You have a whole bunch of analytics. So, for example, we have our own risk factor model, etc. Many different kind of decomposition, financial performance. How do you use that system has been always the challenge. So, for example, hyper customization. We've solved that quite a while ago, right? We're able on our platform, using our technology, to build it. But how do you deliver that to customers? How do you essentially let them use a sophisticated institutional grade portfolio optimizer and they're not necessarily a quant? So one of the things that you see is that a lot of the tools out there which solve these problems are geared towards a certain level of specialism that you need to have. And what essentially the multi-agent system allowed us to do is across these different domains, so whether it's kind of AI alpha, whether it's portfolio optimization and construction, whether it's attribution analysis, performance analysis, ESG characteristics, etc., we were able to create specialized agents and then have an orchestration layer, which would then help either simultaneously understand the data they're seeing in front of them, understand the system, and what you see recently. So if I take a step back in our journey, before it was kind of question and answer kind of system, so kind of analytics describing back to you. What we've been able to see recently with the multi-agent architecture is that it can do stuff for you. So a concrete example for that is, I have a client, they come in, they want something like, okay, build me a US tech portfolio with some kind of decarbonization objective in there as well. And before that, the tools are there to do something like that, but you would need to have a certain level of specialism to do that. Now, essentially with the multi-agent systems, they can access those tools, which have been, refined over the years, so very specialized, and then be able to present that data and that kind of results to the user directly. We essentially built a kind of explainability model on top of our foundational model. But again, that presents a lot of data where you kind of need to be a specialist to understand it. Now, if I want to understand why are we overweight or underweight, it can not only look at kind of the signal from the alpha perspective and the data causing it, but it can look at your portfolio, your objective, your risk constraints, put that all together and then give that in a very digestible way where you don't need to be a specialized to tap into all that data.
It sounds like a lot of the heavy lifting you're doing. Do you have any interest, I suppose is the best thing, in providing some sort of vibe coding interface where the clients can do exploration?
Yeah, so the platform through the multi-agent system now allows them to play around and do kind of a research process of trying out different strategies.
Yeah.
So like I said before, if I wanted to, I'll give you an example of something I did the other day. It was around a series of kind of ESG tech portfolios, and they was able to spin out 10 different variations, run those, analyze them, understand the attribution, and then make iterations on that and do a round 2 and a round 3. There's still a judgment there in the loop, right? It's not like you then deliver that automatically, but that kind of research process, which would have taken with our technology, say 2 years ago, which was already fully API, full Python SDK, etc., would have taken me days, maybe a week to do. I could do that now in, a fourth of the time. What
decisions are agents taking on? What decisions are they likely to take on in the future? And how will agents interact with their human, users?
What I see right now, I think what I mentioned earlier is we see now agents taking on lightweight decisions of like, should I use the image search catalog or should I use the product search catalog and things like that. And the reason why the decisions they are taking at the moment, at least again with the work I'm doing with customers, are lightweight is because, as Yasin mentioned, these agents are not deterministic. So we need to have make them decisions that are not as consequential and where we have some good objective function that we can measure then the performance of the entire system against. The more complex the decisions will be that these agents are taking, that also means the more complex will be the evaluation process. How do you evaluate, whether an agent booked you a good vacation or not? Like, what does that even mean? So there's a lot of thinking that we need to do ahead of, like, right now we could already have these agents make consequential decisions. We just don't know, how to even evaluate that. So I feel like there's a lot of thinking that we need to do up front in order to make these more complex.
Good, thank you. We'd now like to open it up to the audience, and if you'd like to ask a question.
How do we avoid all coming out with the same outcome? If I use AI for research, if I make it an integral part of how we run money, how do I not come out with the same outcome as the person sitting next to me if I'm asking them the same questions?
I've actually been asked this question pretty much my whole career. How do you avoid AI or any kind of automation or systematic investment strategies the same? The truth is there are a lot of strategies which do look the same based on training. If you look at, say, an agent system, first off, there are two main components, I would say that. The large language model is only one part, it's one layer. You have the tooling under there and then you have the data. So yes, if everyone has the exact same tooling and then everyone has the same exact data sets, then you could argue potentially. But then on that side of things, large language models are inherently non-deterministic. So you can ask it essentially 10 of the same kind of, or I'll give you an example, a bit more concrete. If you ask it a joke, for example, say a joke on a certain topic, it's not going to give you the same answer every time. Every time it will give you a joke in the kind of context that you asked it for, but it will be different. And the same with, if you ask 10 economists 10 different questions, right? The same question to 10 economists, you get kind of 11 different answers. This is actually a problem that I have. I don't actually necessarily like that behavior because it's hard from the evaluation perspective to kind of measure these things. But there are so many nuances, and nuances is probably not the right word. It's much bigger than nuances, of subtly changing the system and how it behaves. So you have an investment process. Every company has an investment process and an investment philosophy. The questions you'll be asking, you might feel like they're necessarily the same, but different companies will go about it in a different way.
I have a question about the real user case to use AI in portfolio management. A real user case is, for example, today I have been thinking about rising geopolitical risk. So different scenarios. One is if the situation escalates from here, how should I adjust the portfolio, equity portfolio? If the geopolitical risk kind of goes away, how should I handle the portfolio or adjust it?
Two components to that. So I would say that to solve something like that, I would not rely solely on a large language model. This is again a mixture between a specialized model and the large language model. So to be a bit more specific, let's say, for example, you put something into the system, you ask how's the geopolitical risk, and it says you have massive risk and exposure to, say, US X companies, right? And then you should adjust those. By adjusting those, you might completely mess up your composition of your portfolio and introduce many other risks into your portfolio, which you're not captured in. And that's where NLM would kind of struggle to understand the multiple kind of complexity of different kind of risk factors in your portfolio, and changing one because it has an assessment of one is not related to all the others. And then you have essentially dependencies between those as well. And that's where you have, again, something where you need a kind of, it needs to be connected to a portfolio kind of optimization or construction or a weight management type system, which can evaluate your judgment on those in the context of all your other kind of portfolio characteristics. So this wouldn't be a case where I'd say, okay, a foundational model like a Gemini, you just put in this message into ChatGPT or whatnot, and you get an answer. It has to be connected and have an architecture around that to protect that. Now, your second part of your question is, can it predict stuff that has not happened yet? So the short answer is no. It's trained on data. If there is something completely a black swan event, then you shouldn't be expecting an AI system to kind of predict those kind of things. What we found, for example, if you look at how our AI system and our alpha system, so not really on the agent side, but the actual kind of prediction side of things, the deep learning systems that we use there, they can't predict, say, for example, the credit crisis, right? It doesn't predict. But it was able to react very quickly after the initial impacts of the credit crisis because it had seen kind of, the after effects of similar kind of events. and be able to manage the risk and act very accordingly.
Hi, thank you. Great panel. Thank you very much. So what have been your experiences around user adoption of large language models or RAG or vector or even DSLMs? And how are the portfolio managers reacting to this? Because it's such cool technology, it's so powerful. I guess that question is a great example of people trying to figure out what this could do for them, because it's magical.
Obviously, first impressions looks great, but there is a little bit of kind of a jump before they actually start adopting. But those who do see great value in it, because there's one of the things I was saying earlier. If you want to kind of expose users to kind of very kind of, say, institutional, sophisticated kind of, in our case, like kind of quant technologies, traditionally it's either daunting or you kind of need to be a quant expert to kind of interface with those. And what the LLMs and the kind of the agent-based system is allow them to basically use and interact with these systems in a much more kind of comfortable way.
Hi. I'm curious, between the thing that you mentioned, the tooling, the model, the prompt, and the data, what is a utility and what is actually a key value differentiator?
There is a opinion that is shared by more and more AI practitioners that the underlying foundation models at some point will become a utility. We alluded to that earlier, that the models become all like samey, whether you ask a question to ChatGPT or to Claude or Gemini, you usually get very similar answers. So there might be an argument for saying that these models become commoditized. I think the value, and super biased here as an AI engineer, I think the value comes from orchestrating these large language models. And the value that my data or the customer's data will bring to that system. So again, how do I orchestrate a multi-agent system in a way that it gets the best results for our customers? Am I gonna have an architecture where I'm gonna be speaking to like the manager or the orchestrator, and that one then delegates to several sub-agents that are all specialized? Or do I have more like a system where each agent is equal and they're gonna have like meetings in order to vote on a decision? Like all these things, there's like, if technology stopped today, we had still 20 years of research that we could do on all these kind of things.
So the final thing is what comes next, okay? What's the future of AI-driven investing?
So a couple of things. I think one of the main things we'll see is from a client serving perspective, there'll be a lot of more kind of customization be able to offered. So basically customization and hyper customization we see as a big future unlock, because while some of the autonomous part of the aspects, the building of the strategy was solved in a very kind of quantitative way, the whole client servicing aspect of it as well can now be fully automated. Well, will lead to being fully automated from a agent side of things. So I think being able to offer our clients and our customers much more personalized, customized experiences is one of the big kind of unlocks, both from kind of how much energy it would normally kind of take to kind of deliver that, so, and how much cost and how much time it would take. And I think this can be all unlocked by the kind of multi-agent paradigm that we're seeing into the future.
What I do see coming next in just general the future of agentic AI is agents becoming more autonomous. One example is actually commerce, where Google and other companies are thinking now about a future where agents will shop on your behalf. So Google has introduced a commerce protocol as well as a payment protocol. So basically trying to answer these kind of questions. What does the future look like where shopping is not like a transaction, but it's just a conversation that you have with your agent that then acts on your behalf? Also, how does the communication and the UI gonna look like? I think you asked earlier a question as well, like, if an agent makes a decision, like how is that communicated to the human? How does that UI look like? That is something we at Google will be tackling as well. Like, what does it mean when you give an agent a task and then you don't get immediate feedback like from an API, but the agent goes away for an hour, a day? How often do you get status updates? Where do you get them? When do you try to involve the human? Like all these kind of patterns, we will try to figure out.
Mikhail, can I ask you, what breakthroughs do you think are still needed from a research standpoint?
Yeah, I think that the continual learning is one of the breakthroughs we need to make these models like really going next step towards AGI. And this is why all this memory stuff is so important, because it provides a substrate for continual learning.
I think memory is a key aspect missing. We tackle that problem on ourselves, how to incorporate memory. There isn't a kind of well-defined direction to go in yet in that side. I mean, there's lots of different approaches, but nothing kind of concrete. I think how multi-agent orchestration, the general kind of framework, how you do it is very bespoke, but there is a kind of framework. A framework in terms of kind of from a memory perspective is a lot less clear. So I think that's a key aspect. I'd also say that, funny enough, not only is memory an issue, that's something that we're kind of looking at, but the human in the loop is another one that we're trying to tackle as well.
I've really found this absolutely fascinating. I hope the audience has as well. And thank you very much for actually showing up now. Right?